המשימה שלנו תתחלק לשלושה חלקים. כל אחד יבצע את החלק שלו ויבצע אותו באופן מושלם. ברור? ברור.
Let's build the circuit. First, I'm going to place the photoresistor and the 390 ohm resistor, creating a voltage divider circuit that goes back to the microcontroller analog pin. Next, placing the LED in series with 220 ohm resistor back to a digital output pin. And the passive infrared sensor takes 5 volt from the microcontroller and goes to a digital input pin. Okay, let's go over the code. First, I'm going to declare some constant integer variables for the components. The LED is going to digital pin number 3, PWM pin, to be able to make the LED fade in and fade out. In the setup, I want to be able to talk with the serial monitor, so I'm going to use the serial begin function. Next, I'm going to initialize the pin modes for the components, the LED as output and the motion sensor and the photoresistor as inputs. In the loop section, I'm going to declare a new integer variable called sensor to take the analog read from the photoresistor. Next thing, I'm going to check if it is nighttime. So if the sensor is less than 30, that means that we are at nighttime. Next thing, I'm going to check if we can detect any motion, creating a new boolean called motion. So if motion is true, next thing I'm going to check if the LED is on or off, creating a new boolean LED on. If the LED is off, I want to create delay using the millis function. So current time minus previous time equal period. Now I'm going to declare some unsigned long variables. Previous time, period, let's say around 25 milliseconds, and current time. And of course, current time is going to take millis function. For the light to fade in, I'm going to use the analog write. LED takes I plus 1, and previous time equals the current time to making it count again 25 milliseconds. This if statement going to light the LED by steps every 25 milliseconds all the way to I equal 255. That means that the LED is on. If the LED is on, creating a new delay period wait that is going to start counting after the LED is on. Declaring a new unsigned long period wait, let's say around 30 seconds. In the same way, creating a fade out analog write, LED takes I minus 1, previous time equals the current time. That's gonna go all the way to I equals 0, LED is off and motion is off. Okay, let's check. Let's compile, of course there's problems. Period wait. Integer I equals 0. Digital write LED as low just in case in the setup. Just realize what's gonna happen if the LED is on but the light sensor is above 30. I don't want the LED to stay on, so I'm gonna add motion to the if statement. And another upgrade, if I equals 255 and we detect motion, I want the LED to stay on. So previous time wait equals the current time, making it count the 30 seconds again. If I is less than 255, that means that the LED is fading off. So if we detect motion at this point, making the LED on as false to turn the light again. And of course only if the LED is on. I'm going to serial print the sensor value just to making it more accurate later. Okay, let's compile. Some more fixing. Let's upload. Okay, the sensor value is around 55. If I'm covering the light sensor, it goes down to 7, so let's make it 15. Okay, let's see what we got. Motion is lock, covering the sensor. The LED is turning on, then turning off. Again. Daytime, the light still goes off. Second motion while LED turns off, making it turn on again. Let's add transistor to the circuit to be able to use 12 volt LED. The gate takes the digital pin output. Drain takes the negative terminal of the LED and source to ground. And it's working.